model just to get an idea how we have. The main model has four main parts. There is a characterization of organic materials. It is really important if we want to optimize processes for biochemical treatment of organic waste. And I emphasize on biochemical because we use only biochemical, not thermochemical processes, because they do not replicate natural cycles. We only use something that we can find really in the nature. So we have used composting and anaerobic digestion, but in order to optimize the processes, we needed to know what kind of organic waste we have. So the characterization is really important. We need to identify the organic waste sources that we have looked at three main sources of organic waste. That was communal activities, and there you can find organic waste from households. We could find a green waste from the parks in the city, and there was it is hypothetical wastewater treatment sludge, because the city that we have done our research on does not have a wastewater treatment plant, but we have included as a possibility if something changes that the model could adapt to new circumstances. There is also agricultural. When we looked at waste from agriculture and waste from the farms. And also there is a food industry, and it's really big on waste. There is a lot of waste, especially when we know that Serbia is mostly agricultural country. As far as characterization, the most important was to know the volume or the quantities of the organic waste that is produced seasonally and by location, because we needed to calculate transportation costs. Then elemental composition, in order for us to optimize the processes of anaerobic digestion and composting, we needed to know the elemental composition by itself, because of the processes of degradation, aerobical or anaerobical. C/N ratio, it's always really important when it comes to biochemical processes. And of course, the nutrient profile, because we wanted to know how we can return the nutrients back to the soil from which the organic waste was collected. Then there was the optimal mixing. Because none of the organic wastes is adequate for a treatment by itself. You can always it is important to mix it with some other organic materials to get favorable C/N ratio, moisture content, also available quantities, and the nutrient content in the compost. This was all done by multi-criteria optimization. There is something called global criterion and Pareto optimum point, because some of these criteria are conflicted. After that, there was a really big transportation costs. It was really difficult to determine the routes and the fuel consumption for those routes, because I don't know if you know, logistics and route optimization is really difficult, especially if you have a lot of small sources of waste, such as households. And after that, it was important for all the compost to be brought back to the fields from which some of the agricultural waste, also parks, was collected. And then, of course, there is energy and matter balance. The main idea was to see if there is enough organic waste to produce enough biogas to treat and transport all of the organic waste that we want to treat and transport in the area that we were looking at. When it comes to organic materials, we focused on carbon content, nitrogen content, C/N ratio, dry moisture content, also generated quantities, and some inhibitors for the process. For the substrates, I already spoke about this. We used urban communities, agricultural, and food production sector. The main available feedstocks that were looked at for this particular study, they were organic part of municipal waste, also park waste, here labeled as garden waste. And there is a milk industry in the city, so we looked at dairy waste. And also, because there is a brewery, we looked at brewers' grains. As you can see, there is significant amounts of waste that is generated. There is around 9,000 tons of organic fraction of organic waste or organic fraction of municipal solid waste. There is also a really big amount of waste from the park. Not so much from the milk industry, because that kind of waste is actually a lot of waste in the milk industry is actually reused and resold. So there is not a lot of those kind of waste, but it's really good on proteins. So it is used for optimizing C/N ratio when it comes to anaerobic digestion. And when it comes to brewers' grains, there is a lot of it, around 9,000 tons, similar as organic fraction of municipal waste. So as I said, the global criterion was used, simplex method. There was a Pareto optimal point, because a lot of the criteria are conflicting and they should be considered simultaneously. So when it comes to the problem, it was designed mathematically according to three functions. We looked at carbon content in each of the substrates, nitrogen content, and also here the moisture content, because we wanted to be sure that we have enough C/N ratio for microbial activity. It is usually in between 20 and 30, and enough moisture content for the hydrolysis to happen. And of course, the constraints were that you have to have 100% of all substrates, and that we use all of the substrates that are available. After that, we have got 8 different scenarios of a closed loop system based on optimal mixing ratio of different organic substrates. There is a few of them basic. Baseline scenario 1, when we have only organic fraction of municipal solid waste and garden waste. Also baseline scenario 2, when we have also those two, but one is dealt with an anaerobic digestion, the other one with composting. Then we started adding different substrates to the model. Then we have three different scenarios that include three substrates, and then three that include all four substrates found in the area. And the last one includes both anaerobic digestion and composting. Just we wanted to know how the closed loop system would react if there is both processes available. You can see also the optimal mixing ratio, C/N ratio of the mix of the final mixture and the moisture of it. Then there was a part of collecting and transport. The easiest way was to transport organic waste and the product compost. There was an optimization of the routes in appropriate time intervals, because you cannot leave organic waste for a very long time. It usually, the time interval was 7 days. And when it comes to the compost produced, it was transported back to the fields in time of need, so in fall and in spring. The fourth part was energy and matter balance. And for this research, we developed 5 indicators of circular economy, just so we can track the efficiency of circular economy in the closed loop. There was leakage of matter, so we wanted to know what so the leakage of matter is basically a surplus of matter that it cannot be used in a closed loop system, of there isn't a need for it. Also, leakage of energy. It's a surplus of energy, but we have not identified a need for that kind of energy. But it means if you have a surplus of energy, it means that you can widen your closed loop system, or include some kind of different production. So there was also a degree of incorporation of organic matter. So we had amount of organic waste that is generated. We wanted to know how much of organic waste we can actually put in a closed loop. Also, we have done matter circularity. So how much of the matter of the compost and the organic waste actually stays in the closed loop system. So how much circulates, and also when it comes to energy, we wanted to know how much energy circulates inside of the closed loop system based on the requirements and the energy gains from the biogas. So for all of those scenarios, we had a different way of looking at how much looking at circular economy indicators and what do they actually show us. We have leakage of energy. It's actually leakage of matter, and it's actually the surplus of compost, because we take the compost, we take organic waste not only from the fields but also from the industry, and we don't have enough fields to return the compost to. So the main conclusion was that we have to widen the closed loop system and include maybe more of the agricultural households. and give them back a compost as a way of naturally fertilizing the fields. Also, there was a leakage of energy. When it comes to processes that only have composting, they have a negative value of the leakage. So we need to put energy efforts into the closed loop system in order to functions. And from this, we can see that the best way for a closed loop system to work when it comes to organic waste is actually to have both anaerobic digestion as a source of energy and composting as a source of nutrients. When it comes to the degree of incorporation of organic matter, when it comes to anaerobic digestion, there is always 100% incorporation because anaerobic digestion is more flexible for different kinds of organic materials. As far as composting, it's more pickier. So not everything could be composted, or not every quantity could be composted. But we can see also for the scenario 6 that also there was a surplus of energy, but there is 100% of incorporation. When it comes to matter circularity, the best matter circularity is, of course, where there is composting, because we return the nutrients to the fields, but also the scenario that has anaerobic digestion and composting has a really good matter circularity. It means that 80% of the nutrients are circulating through the closed loop. Also, it is the lowest value of all scenarios. When it comes to energy circularity, 70% of energy is usually used for transportation and treatment of organic waste, also, and the products. When there is a combination of anaerobic digestion and composting, because composting is less energy demanding process, so you don't have to heat the substrates. You only need to transport it. There is a higher circulation of energy. It's up to 80%. So what we have achieved 100% of the degree incorporation of organic matter in the closed loop. Also, the matter circularity can be achieved up to 91%. There is energy circularity up to 80% when there is a combination of anaerobic digestion and composting. Also, really important, 27,000 tons of organic waste in 1 year could be treated and integrated in a closed loop system at the city of Niš, and that is 27,000 tons less waste that ends up in landfills. I'm just gonna go quickly through conclusions. So it's really important to have a linear to circular transition, especially when it comes to organic waste, because it's really a resource and it's really difficult to manage because of its characteristics. Also, there are determinants of system performance. So there should be a balanced feedstock mixtures. Also, we need to have more than one biochemical treatment options. There are critical parameters such as C/N ratio, lignin content, and phosphorus concentrations. Then, as I have mentioned before, synergy of treatment pathways. It's important to combine anaerobic digestion and composting, maybe even include fermentation. And also there should be a restitution of essential micronutrients such as nitrogen, phosphorus, and potassium back to agricultural soils. There was a validation done for the model in a small city in Serbia, and we have shown that model is reproducing real system dynamics. Although it's developed for Serbian contexts, it needs to be transferred to other regions with some hypotheses and their organic waste generation patterns, and also policy and practical implication. There should be a policy change in organic waste management, or also there should be integration treatment technologies that support nutrient cycling, renewable energy production, and reduction of greenhouse emissions. And for future direction, there should be an expansion of feedstock database, realignment with circular economy indicators for more precise evaluation, and also to see application of the model in some international case, just to validate the scalability of and replicability of the model itself. Thank you for your attention.
Thank you, Anna. Your PhD research and thesis is depth sub-areas in circular economy, and it is very important for this area, such as circular economy. I would like to say something about your presentation. Your presentation details analysis of the current practices and needs for improving organic waste management in Serbia, which is particularly important since organic waste represents a large share of total waste. And when managed properly, it can become a valuable resource. Anna also referred to circular economy indicators relevant for organic waste. These indicators are essential to monitor progress and guide decision makers in developing effective local strategies. We are in the technical areas and we see only quantitative analysis and quantitative area.
Yeah.
And I have one question for you. Based on your findings, your research, what would be the first practical step the local municipalities in Serbia and this region could take to improve organic waste management?
Maybe first step would be separation, because right now it's collected so we don't have a separation system in Serbia, in my city, I'm sorry, in it. First step would be to separate organic waste and to collect it, because they basically collect it via the same routes, just in different times. And composting facility, it does not have a very high capital investment. So it would not be very expensive to maybe start composting and then think about maybe of an aerobic digestion, because it's a little bit more pricey. So maybe they should start collecting organic waste separately and start composting it, and then maybe think about widen it to anaerobic digestion, because the capital costs are more expensive.
Thank you. I wish you the best of luck with your research and the completion of your PhD thesis. Now I open a short discussion. If anyone has any questions. Finally, I would like to introduce Professor Dr. Katarina Bojkovska, our MC from North Macedonia. Her affiliation is Faculty of Biotechnical Science, Bitola, University St. Clement Ohridski. Katarina, are you here?
Yes, hello everyone.
Can you share your
Yes,
presentation?
I will share my
Title.
presentation now. Is it okay?
Yes, I have just a problem with my mouse. Okay. Katarina's presentation is Circular Economy, Global Concept for Sustainability. Please, you can start, and welcome.
Good afternoon, everyone. It is a great honor for me to take part in this webinar. Thank you for organizers. Thank you, my colleague Isidora Milošević. Thank you for Action Chair Olesea Plotnic. For the invitation, as well as thank you for all colleagues and participants at this webinar today. I hope that my presentation will contribute for a fruitful future collaboration between us, and we can exchange some ideas after this webinar. My name is Katarina Bojkovska. I'm a full-time professor at the Faculty of Biotechnical Sciences. My research area is connected with agribusiness, and today my presentation will be Circular Economy, Global Concept for Sustainability, with accent on agricultural circular economy in agri-food sector. I'm coming from University St. Clement Ohridski Bitola, Faculty of Biotechnical Sciences. I will start with sustainable development as a challenge of modern world. Increasing and improving the quality of life of people is the main goal of every society. Sustainable development is a complex process whose main task is to ensure balance in the world through economic, social, and environmental positive effects, and includes changing the current way of life, attitudes, values, habits, behaviors, and actions at all levels of society, from local, regional, national to global levels. Sorry. And this is some definition of the United Nations about sustainable development that meets the needs of the present without compromising the ability of future generation to meet their own needs. The Sustainable Development Goals are part of the new global agenda and Millennium Development Goals, and a global call to action. On this diagram are illustrate the multidimensional nature of sustainable development. It is not just about the environment, but it is a balance between four key sectors. They are social, culture, economic, and importantly, human vitality, which places people's well-being at the center of the development. Essentially, this picture shows that sustainable development is only achievable when economic aspirations, social justice, cultural preservation, and human well-being are harmoniously balanced. Sustainable development today is a framework for formulating policies and strategies for continued economic and social progress. The use of recycled materials, the rational use of increased efficiency of resources, and changes in consumer habits will ensure a high level of protection and improvement of environmental quality. The motto of sustainable development is enough for all, forever. That means that sustainable growth based on a responsible use of natural resources, the highest possible degree of synergy between environmental protection policies and social economic development, and demand for resources from the nature to meet the needs of humanity to be bigger from what nature can provide. It is most important. basis of the concept of sustainable development of each country is investing in an integrated policy to reduce air pollution, build resilience to natural disasters and climate change, and promote low carbon to promote low carbon growth. In my country, in the Republic of North Macedonia, they are precondition for serious progress on the path towards sustainable development. Global sustainability is a challenge of modern times to meet some broader global demands, and it is a necessary process in the long term and leads to significant global benefits. The traditional linear model of the modern economic system is unsustainable, and its principle is take, make, use, and throw. Phases of the linear economy model are presented on the figure: raw materials, production, distribution, consumption, and waste. About 20% of the world's total population uses about 80% of the total resources, leaving the remaining 80% with only 20% of the resources. A new economic model is necessary, and the recent European proposed solution is precisely the circular economy. The first official document at a global level on the topic of changing economic development towards the concept of a circular economy was published in 2012. Under the title Towards Circular Economy, it highlights the enormous potential of the circular economy in creating financial savings. According to Murray et al., a circular economy is defined as an economic model where planning, resource supply, procurement, production, and processing are designed and managed both as a process and as an outcome to maximize ecosystem functioning and human well-being. The circular economy is a regenerative economic model that has a positive impact on all types of capital: financial, human, social, and natural. It aims to renew natural resources, keep raw materials in use, and extend the life of products by applying appropriate design and turning them into raw materials instead of waste, so that they don't contribute to environmental pollution. Modern global trends aim to replace the deeply rooted linear economy and waste management with a circular economy. The transition to a circular economy represents not only an opportunity to solve the triple planetary crisis of pollution, climate change, and biodiversity loss. The circular economy also supports the protection of human rights by ensuring sustainable development, global security of natural resources, climate change action, energy security, and enough food for all. The current concept of a circular economy initiates a movement from some concept of a circular initiatives, a movement from the concept of a linear economy based on systems with intensive consumption of natural resources, high CO2 emissions, waste generation, and negative environmental effects, towards circular and less waste systems that use resources more efficiently and sustainably while providing job opportunities and a high quality of life. Circular economy model is presented on that figure, and we can see that phases of circular economy model, where at each stage of the circular cycle it is possible to reduce costs and dependence on natural resources and the accumulation of waste material from one production process enters as a resource into another process. In the transport phase, efforts are made to achieve the greatest possible energy savings and the least possible environmental pollution. The end of the cycle is marked by the collection and recycling phases, where the main goal is to reduce as much as possible the amount of resources that leave the system and up as waste. In a circular economy, waste generation is minimized through the careful design of new products and industrial processes in which materials are constantly circulated in some closed system. Waste has become an exceptional problem across the planet, and raw materials are in greater demand than ever. It is estimated that around 80% of all consumers' goods and materials are discarded, and that over 30% of processed food is wasted upon entering the food supply chain. The application of the circular economy concept encourages environmental protection and social prosperity while enabling economic growth in line with sustainable development. The circular economy can reduce environmental destruction throughout the system as well as increase the creation of new added value. The circular economy model implies a paradigm, a shift in resource management in an efficient and smart way. The concept of circular economies consists of use of renewable energy sources, eco-innovation, eco-design, advanced technologies, and energy efficiency. Some principles of circular economy are presented on this slide. The circular should be turned as many times as possible. One of the principles is maintain and repair the products, reuse, donate or resell, repurpose, recycle or compost, and ultimately, instead of landfilling, use it for energy. The substantial contribution to the EU's efforts to develop a sustainable, low-carbon, efficient, and competitive resource economy. The concept of a circular economy is a key contribution to 2030 Agenda for Sustainable Development. In 2015, the European Commission adopted a new legal framework to introduce a circular economy model. The European Green Deal is the roadmap towards transforming Europe into the first climate neutral continent by 2050. The EU Strategic Agenda 2024 to 2029 is already taking shape with a focus on security, economic sovereignty, green transition, and enlargement preparations. The new EU strategic guidelines are security and defense, economic resilience, green transition, and enlargement preparedness. There are some circular economy policy laws in my country, in the Republic of North Macedonia. The most important is law on waste management and law on packaging and packaging waste management, and some other laws which are connected with circular economy. In general, all 6 laws provide a set of measures that lead to a circular economy,
%65'i kadın, %70'i
encourage waste collection and treatment, provides a solid foundation for the development of waste management, raises the responsibility of the producer, contributes to reducing waste generation, and encourage eco-design of products. The most important, how I said, law on waste management. This law aligns with Directive 2008 from a European Commission of the European Parliament and the Council of 19 November 2008 on waste and repealing certain directives. There are some benefits of the circular economy for companies, creation of new jobs, innovation and competitive advantages, cost reduction, reduction of energy consumption and CO2 emissions, and greater security of the supply chain and resources. There are some business models related to circular economy. The first group are business models that integrate and encourage reuse, repair, remanufacturing, and upgrading into their operations. And the second business model that turn all the goods into new resources through recycling. A circular business model is a business approach that aims to eliminate waste and sustainability use resources. It contrasts with the traditional linear model, which was take, make, dispose by closing resource loops. There are some key principles of circular economy ecosystems: refuse, rethink, reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, and recover. Linear business models are based on the following logic. Take natural resources, make products for consumers that eventually become waste, design out waste and pollution, keep products and materials in use, and regenerate natural systems. If you compare linear with circular business models, we can conclude that there are so many benefits from the circular economy business models. They transforms our current throwaway economy, eliminating waste and pollution and circulating resources, tackles climate change and biodiversity loss simultaneously, separates the ability to achieve economic growth from the consumption of natural resources, create jobs, prosperity, and resilience while cutting greenhouse gas emissions, waste, and pollution, and presents a business case for each sector to be more sustainable while increasing competitiveness. The concept of a circular economy implies the success of companies that are better than their competitors in adding value, but also for society and for the environment, for consumers and investors. Some challenges of the circular economy are the following: absence of appropriate regulations, after that, lack of environmental education, lack of culture for environmental preservation, and insufficient interest from consumers in the market. Circular economy is a big challenge to minimize waste and increase the profits of companies in agri-food sector. Why circular economy in agri-food sector? It reduces costs through resource reuse, increases profitability for agri-food companies, alignment with the United Nations Sustainable Development Goals, especially SDG 12, responsible consumption and production, and SDG 13, climate action. There are some environmental, economic, and social benefits, and some global perspective. It reduces pollution, improves health, and preserves biodiversity. It strengthens local food systems and promotes sustainable agri-food communities. There are some key principles of the circular economy in agriculture. First is using waste as a resource. Second is regenerative agricultural practices, efficient use of resources, renewable energy integration, and shortening supply chains and localizing food systems. There are some examples of circular economy practices in agriculture. First example is composting, or turning food and crop waste into organic fertilizers. After that is agroforestry, integrated trees into cropland to improve biodiversity and soil quality, regenerative agriculture, rotation of planted crops, cover crops, and reduced tillage to improve soil health, biogas production, converting manure and organic waste into renewable energy, precision farming, using technology to optimize inputs, reduce waste, and increase efficiency, and water recycling, treatment, and reuse of water for irrigation. These infographics shows global food challenge, just how big the big problem of food waste is in the world. 1/3 of all food produced never reach consumers. That's 1.3 billion tons a year. Food waste causes 21% of total greenhouse gas emissions, while at the same time leaving also almost 1 billion people undernourished. In addition, by 2025, 1.8 billion people will live in regions with water scarcity. This highlights the need for more sustainable habits and better resource management. In the EU, almost 57 billion tons of food waste are generated annually with a market value estimated at 130 billion euros. Eurostat estimates that around 10% of the food available to consumers in the EU in retail, food services and households may be wasted. Food waste management covers the stages of prevention, recovery, recycling, or disposal of food waste, namely tracking and prevention of food waste, food banks using food as animal feed, generating renewable energy through anaerobic digestion. Similarly, in the EU, households generate more than half of the total food waste, 55% of the in the EU, with 71% of food waste arising from households, food services, and retail. These data are from the Eurostat. Food waste is not only an ethical and economic issue, but also depletes the environmental with limited natural resources. The EU is committed to meeting Sustainable Development Goal 12.3 to halve global food waste per capita at retail and consumer levels by 2030 and reduce food losses throughout production and food supply chains. Reducing food losses and waste will significantly help achieve the Sustainable Development Goals. In the Republic of North Macedonia, there is surplus of safe food that can be reused, recycled, and properly handled, thus creating as little food waste as possible. In doing so, the focus should be not only on the environmental, social, and economic benefits of preventing food waste, but also on the opportunities for applying green principles in the operation of agri-food businesses. Appropriate responsible investment by agri-food companies will result in a sustainable value chain as circular economy policy, and waste management practices will add value to agribusiness, the environment, and social as a whole. Reducing food losses and waste will significantly help achieve the Sustainable Development Goals, but in this way, it will also enable supporting the fight against climate change. Food waste alone generates 8 to 10% of global greenhouse gas emissions. Saving food and redistributing it to those who need it, helping to indicate hunger and malnutrition, saving money for farmers, companies, and households. Food is lost or wasted throughout the full supply chain on farms, in processing and manufacturing, in stores, in restaurants, and also in homes. The main objective of EU food safety policy is to protect human and animal health. These standards can be met in cooperation with EU member states and stakeholders who should find ways to prevent food waste and strengthen the sustainability of the food system. By the 2050, the global population is projected to grow to around 10 billion people. Unless production and consumption patterns change, there is a risk of depleting the planet's resources. A circular agro-food system makes it possible to produce enough food for everyone within the limits set by the planet. On this figure is present circular agro-food system. And for conclusion, focusing on promoting the application of the circular economy concept is very important, providing capital, secure jobs, training and leadership opportunities for young people from rural and other communities who contribute to a circular transition. Educating young people is key to the transition to a circular economy. Young people are the builders of the future and must play a more prominent role in the transition to a circular economy and in advising business and political leaders on the most critical issues facing the planet and its current and future generations. It is essential to engage young people in acquiring the knowledge and skills to build a circular economy. Governments, through their regulations, can help the economy with appropriate green policies, taxation, promoting a circular economy, and attracting green investments. Scientists have the opportunity to increase research and development of this topic and implement new methods with innovation and sustainability. And I will end with some quote from Ken Webster. The circular economy gives us the opportunity to build a system that can work in the long term, and the time is right for it to reach scale. There is no planet B. Thank you for your attention.
Thank you.
Thank you, Professor Katarina, colleagues. Our timeline looks very good. Okay, Professor Bojkovska, gives a comprehensive overview of the circular economy with a particular focus on agriculture and the food sector. She provides a broad and insightful perspective on the circular economy as a global concept for sustainability. Her presentation emphasized that circularity goes beyond individual sectors and represents a systematic shift that affects production, consumption, and social value worldwide. By highlighting key principles, 4 principles of circular economy, such as resource efficiency, waste minimization, creation of closed loops. She reminded us that the circular economy is not just a technical framework, but also a cultural and policy-driven transformation with clear benefits such as resource savings, innovation, and reduced environmental impact. In this sense, circular business models, how she said, plays an essential role in translating the concept into practical sustainability solutions. This global lens is particularly relevant for understanding how local and the regional initiatives can be aligned with the international strategies and sustainable goals. Also, Professor Bojkovska offered a broader perspective of the circular economy challenges in the agriculture and food sector, which is particularly important for countries in the region where this sector plays a key role in economy. Her presentation reminded us that the circular economy is not limited to industrial production, but it also highly relevant to agriculture, food processing, and preservation of resource, especially in rural communities. The practical examples she showed that innovations in biotechnical science, in agricultural science, can deliver concrete results and contribute significantly to sustainability. I have a question for Katarina. In your view, which innovations in the agri-food sector have the greatest potential to accelerate the transition to a circular economy in the Balkans?
Thank you, Isidora. In agri-food sector in the Balkans, innovation that turn waste into resources such as composting, biogas from organic residues, and precision farming technology have the greatest potential. These solutions directly reduce food waste, save resources, and create new value, which is the essence of the circular economy. The greatest potential lies in innovation that use agro-waste for biogas and organic fertilizers, and precision technology like sensors, satellites, digital platforms that reduce the consumption of fertilizers, pesticides, and water. In this context, there are some challenges. that hinders rapid innovation, and there are small farms which are dominant in the Balkans, often lack the capital to invest in sensors, in drones, and digital platforms, which are very expensive for them, lack of training and digital literacy. If users don't understand the technology, they won't adopt it, and regulatory and some financial barriers like a legal framework, subsidies, access to some credits are also the very big challenge for introducing the innovation in agri-food sector.
You. Now I open a short discussion. If anyone has any questions.
For people who think for a question, because the presentations were really interesting for all of us, I would like to propose to our participant to switch on the camera if they are available to take a picture. After that, we'll post on our social media. This is really important for us, for our visibility. Thank you a lot. Just for 2 seconds, and after that, we'll continue. Yeah, I will tell you when I will take the picture. Yeah, thank you. Nice. Okay, 1, 2, 3. Smile. Keep your smile because we have several pictures to take. 1 second, one more page. We have 3 pages. Okay, once again, 1, 2, 3, smile. This is done. Thank you a lot. And now
Okay.
questions.
No questions. Why?
And
We
now
open
questions.
discussion.
No questions. I think we have questions. Maybe one question will be
Our
when it is the
speakers
next
were very
webinar.
clear. Our speakers were very clear. And
I want to
nobody had a
inform you that
question.
our next webinar, it is in 2 weeks on 17 October. We will organize a PhD student workshop online. So on social media, you'll find more information, and you also will be invited via eCost. So be in touch.
Thank you. Can I give a final words? Okay, thank you. As we come to the end of today's ECO4ALL Working Group 2 webinar, Practical Guide to Circular Economy, Benefits and Actions to Reduce, Reuse and Repair, I would like to take a moment to thank our distinguished speakers for their insightful presentations and contributions. Each of you shared valuable perspectives that not only depend our understanding of circular economy practices, but also highlighted concrete actions that can be implemented to empower and protect consumers. I would also like to thank all participants for your active engagement and for being part of this important discussion and presentations. First of all, your attending is very important for our network and our community. Special thanks go once more to our action chair, Olesea Plotnic, for her continuous support and encouragement in organizing activities that bring us together and strengthen collaboration across our network. Sorry, maybe you heard my daughter. Today's discussion and presentations about the principles of reducing, reusing, and repairing are not only strategies for addressing environment changes, but also key elements for building sustainable and fair consumer practices. Together, through cooperation and knowledge sharing, we are moving closer to a future where circular economy becomes the standard rather than the expectation. Thank you all once again for your valuable time and contributions. I look forward to our continued collaboration within ECO4ALL network and to future opportunities to share knowledge and drive change together. With this, I officially close today's webinar of Working Group 2. But before that, I would like to give a word for actual chair Olesea Plotnic if she wants to say something.
Thank
Thank
you.
you again.
Thank you, Isidora. I really appreciate your cooperation and of all of us that we are still available online to participate for different webinars. For the next grant period, we intend to organize a big conference in Rome. So be connected to our social media website because we'll inform all of you via emails also. As regards the deliverables, we are still working on deliverable number 8 and 5 as regarding guidelines and strategy for circular economy that works for consumers. Be in touch with our working group leaders because when you're applying for grants, for example, for different mobilities, it's really important to have a support and recommendation of your working group leader with whom you should be in touch. As regarding our publications on our website, ECO4ALL.org, we may find the updates on our publications and deliverables, and soon we'll share our newsletter for grant period 2. So as it is a webinar, we're not able to know each other in person, but we have perspectives to organize in-person events next year in Lausanne, in Malta, a training school in Cyprus. So be connected and be involved. Thank you.
Thank you very much.
Have a nice day.
Thank you.
And I think we can close our meeting. If someone wants to say something, yes, you are welcome. I see David is okay. Goranda, would you like to say something?
I already wrote, but it will be better to say loudly. Thank you so much for the interesting presentation. Today was a very useful day, beginning from the MC meeting until this webinar. Thank you so much. And there were the questions, what made me to think about it in my country. For instance, about agriculture issues and circular economy. Thank you so much. Good luck. And I hope we can meet in next webinars too. Thank you.
Thank you, Goranda. Thank you for all. Stay safe and have a nice day, all of you.
Bye. Bye.
Bye.
Bye.
Bye-bye.
Bye.
Thank you. Bye-bye, all of you.
Bye.
Bye.
Bye-bye, Natalia, Zafir.